Hi everyone, welcome back. Today we're doing final value of variable after performing operations. So this question is a great practice for loops as well as equality between two strings. So for this question, we're given a programming language with only 4 operations and 1 variable x. And each of the 4 operations are like this. We have plus plus x, x plus plus, and these 2 operations increment the value x by 1, and minus minus x and x minus minus decrements x. So we're given an array of strings. Each of these are operations, and we have to check whether if the operation is incrementing or decrementing x, and afterwards we will return the final value of x after performing those operations. So in this case, in the first test case, we have 1 operation to decrement and 2 operations to increment. So in this case, we get 1. For the second one, we have 3 operations, all 3 incrementing, so that's 3. And for the final example, we have 2 operations to increment, 2 operations to decrement, giving us 0. So each of the lists given to us in this case, it would be a length of 1 to 100. So we'll have at least 1 operation, and each of the operation will be one of the 4 permutations listed over here. So this question is straightforward enough to quickly go through the approach. We will initialize a variable x, and we will iterate through every single item in operations and check if they are either an increment operation, increment x by 1, or a decrement operation, decrement x by 1. So with that, let's get started. X will be equal to 0. This would be representing the value after the operations, and we would start iterating through every single string in this case. So once again, this is a reference to the same string in this vector of strings. Editing this would mean editing the items inside vectors of strings. So just to be clear to our viewers, C++ can be a little confusing, especially for viewers like myself who come from a Python background. But in this case, after iterating through every single operation, our step here would be to check if operation is equals to plus plus x or operation is equals to x plus plus. So if this is an increment operation, then we'll increment x by 1, else x will be decremented by 1, like this. So that's pretty much it, and we will just return x like this. So let's try tracing this with a simple test case, the first test case over here, and let's see how our algorithm would work against this test case. So x would initialize as 0, and we will start iterating through every single operation over here. So operation equals to minus minus x. In this case, we will not match line 14. It's not an increment operation, so we will decrement x over here instead. So we get -1. Next will be x plus plus, and in this case, it's an increment operation, so x will be back to 0. And the final operation will be x plus plus, giving us x equals to 1. So that's pretty much it. Looks like this works. Let's run this against the test cases. This passes. Let's submit this. And there we go. So let's talk about the time and space complexity. I noticed that I didn't clear it last time for the first challenge, but I guess that's pretty straightforward. The time complexity for that is ON, but I digress. So over here, we have a list of operations. If n is the size of operations, then in this case, because of the for loop over here, we have to iterate through every single operation. So understandably, this algorithm would be ON in time complexity. For the space complexity, in this case, we use a constant number of variables to keep track of items. We use a variable here that's 4 bytes to keep track of the integer. And for this string, it's going to be more than 4 bytes, but depending on the number of characters, each character should be 4 bytes, I think. And in this case, this is still going to be O1 because we are reusing the same string variable over here. So this is going to be pretty much O1 as well. So that's pretty much it. So space complexity is going to be O1. And that's pretty much it for this question. I hope this was a clear demonstration of the algorithm. And if you like this, please give us a like and subscribe, and we will see you in the next challenge.